Dear Seeker, I'm Stefan. Welcome back to this channel. Today, I invite you to pause with me for a moment and reflect on a quiet but powerful shift taking place inside modern factories. A shift where human skill, advanced robotics, and global cooperation are beginning to merge in unprecedented ways. In early 2026, Airbus, one of the world's most respected aircraft manufacturers, announced plans to test humanoid robots developed in China within its aircraft assembly operations. These are not ordinary industrial machines fixed behind safety cages. They are humanoid robots, built to walk, grasp tools, navigate human spaces, and remarkably, to replace their own batteries without human assistance. The robots are developed by Tech, a company at the forefront of humanoid robotics research. At first glance, this may sound like a small technical trial. But when we look more carefully, it becomes something much larger, a signal of where global manufacturing, automation, and human-machine collaboration may be heading. Aircraft assembly is among the most complex and safety-critical forms of manufacturing in the world. Every bolt, every wire, and every inspection step carries immense responsibility. For Airbus to even test humanoid robots in such an environment tells us that the technology has reached a level of maturity worth serious attention. In this video, we will gently unpack what this announcement really means. We will explore how battery-swapping humanoid robots work, why this capability matters, what Airbus hopes to learn from these trials, and how this development may affect workers, industries, and ethical decision-making in the years ahead. This is not a story about replacing people. It is a story about redefining work, responsibility, and cooperation between humans and intelligent machines. Let us begin this journey together, thoughtfully, calmly, and with curiosity. What exactly was announced? To understand the importance of this development, we must begin by clearly and calmly examining what was actually announced, and just as importantly, what was not announced. In January 2026, Airbus confirmed that it had entered into a cooperative testing agreement with Tech, a leading developer of humanoid robots based in China. The purpose of this agreement is not immediate deployment or mass automation, but structured testing within selected aircraft manufacturing environments. The humanoid robots involved are part of Tech's Advanced Walker series, designed to operate in spaces built for human workers. Unlike traditional industrial robots that remain fixed in one location, these machines are mobile, upright, and capable of using human tools. Most notably, they are equipped with autonomous battery swapping capability, allowing the robot to remove a depleted power unit and replace it with a fully charged one without human assistance. Airbus has emphasized that this initiative is a trial. The robots will be evaluated for basic tasks such as material handling, inspection assistance, and simple assembly support. Safety, reliability, and consistency will be the primary metrics, rather than speed or volume. It is also important to understand the broader context. Aerospace manufacturing is facing rising complexity, skilled labor shortages in certain regions, and increasing pressure to maintain quality while scaling production. This trial reflects exploration, not replacement, a search for tools that can assist human workers in demanding environments. By starting with testing rather than promises, Airbus is taking a measured and responsible approach. This section of the story is not about disruption, it is about careful inquiry, asking whether humanoid robots can earn a place, step by step, in one of the most demanding industries on Earth. In the next section, we will explore the technology itself, and why battery swapping changes the equation. Understanding the technology, battery swapping humanoid robots. To truly appreciate why this development has captured global attention, we must gently slow down and understand the technology at its core. The headline phrase, battery swapping humanoid robot, may sound futuristic, but the idea behind it is practical, purposeful, and rooted in long-standing industrial challenges. Humanoid robots, unlike traditional factory machines, are designed to work in environments built for people. They walk upright, navigate narrow spaces, climb small steps, and manipulate tools designed for human hands. This flexibility makes them especially appealing for industries like aerospace, where assembly spaces are complex and cannot easily be redesigned around fixed automation. However, mobility introduces a critical limitation: power. Most humanoid robots rely on internal batteries, which means their working time is limited. Once depleted, the robot must stop, recharge, or be manually serviced, creating downtime that reduces productivity and complicates scheduling. This is where battery swapping technology becomes transformative. In the systems demonstrated by UBTech, the humanoid robot can autonomously walk to a dedicated station, remove its depleted battery module, insert a fully charged one, and resume work within minutes. No cables, no human intervention, and no extended idle periods. The process mirrors how industrial logistics systems handle tool or pallet exchanges, applied now to robotic power itself. From an operational perspective, this enables near-continuous activity across shifts, predictable maintenance windows, and easier fleet management. From a safety perspective, it reduces human handling of high-capacity batteries and standardizes energy use. Importantly, this capability does not make robots tireless workers. Maintenance, diagnostics, and supervision remain essential. What it does is remove one of the largest bottlenecks to humanoid robot deployment in real factories. In the context of aircraft assembly, where interruptions are costly and precision is mandatory, battery swapping is not a novelty. It is a practical solution to a long-standing engineering problem. In the next section, we will explore why Airbus, in particular, sees value in testing this technology. Why Airbus testing this technology truly matters. At this point, a thoughtful seeker may ask a fair question: why does this trial matter so much? After all, companies test new technologies all the time. The answer lies in who Airbus is, how aircraft are built, and what this decision quietly signals to the rest of the industrial world. Airbus is not merely another manufacturer. It operates in one of the most tightly regulated, safety-critical industries on Earth. Every component installed on an aircraft must meet rigorous standards, undergo extensive documentation, and pass multiple layers of inspection. Even small changes to tools or processes can require months, sometimes years, of validation. Because of this, Airbus does not experiment casually. When Airbus agrees to test humanoid robots on its assembly lines, it is making a careful statement. The technology has reached a level of maturity that warrants serious, methodical evaluation. This alone places humanoid robotics in a new category, no longer just a laboratory concept or a promotional showcase, but a candidate for real industrial responsibility. There is also a practical reason Airbus is interested. Aircraft assembly involves complex, irregular tasks performed in confined spaces, inside fuselages, around wings, and within systems bays. These are environments where traditional fixed robots struggle, but where human workers excel. Humanoid robots, designed to move and operate like humans, offer a potential bridge between flexibility and automation. Equally important is the broader signal this sends. Airbus is a reference company. Its trials influence suppliers, tooling manufacturers, regulators, and competitors. If testing proves successful, it could encourage the development of standards, training programs, and safety frameworks that extend far beyond a single factory. This section of the story is not about speed or replacement. It is about trust. Airbus is asking a careful question on behalf of an entire industry. Can humanoid robots be reliable partners in one of the world's most demanding manufacturing environments? In the next section, we will bring this question down to the factory floor and explore what such robots might realistically do, day by day. What this could look like on the factory floor. To move from announcement to understanding, we must imagine how this technology would appear in daily practice, not in headlines, but on the factory floor where aircraft are actually built. If Airbus proceeds beyond early trials, humanoid robots would almost certainly be introduced gradually and cautiously. They would not begin by performing complex, safety-critical assembly steps. Instead, their first roles would likely be supportive and tightly defined, transporting tools or components, assisting with visual inspections, holding parts in place, or performing repetitive, ergonomically demanding tasks that place strain on human workers. One of the advantages of humanoid design is compatibility. These robots can navigate walkways, climb small stairs, and operate in workspaces designed for people, meaning factories do not need to be completely redesigned. The battery swapping capability further supports this model by allowing robots to operate across multiple shifts without disrupting carefully scheduled production cycles. However, real factories are unforgiving environments. Every new tool must integrate with existing quality systems, digital tracking software, and safety protocols. Robots must demonstrate consistent precision, predictable behavior, and fault-tolerant responses. If a humanoid robot pauses, misaligns, or behaves unexpectedly, production can slow or stop entirely. This is why human oversight remains central. Skilled technicians would supervise robot operations, review data, and intervene when conditions change. In many cases, robots would act as physical extensions of human planning rather than independent decision makers. It is also important to emphasize what will not happen quickly. Full autonomy, unsupervised decision-making, and widespread replacement of skilled labor are either realistic nor desirable in aerospace manufacturing. Progress will be incremental, evidence-based, and conservative by design. On the factory floor, the real measure of success will not be spectacle, it will be reliability, safety, and quiet usefulness. And only after proving these qualities repeatedly would humanoid robots earn a larger role. In the next section, we will turn to a crucial human question: how this technology affects workers, skills, and ethical responsibility. Workforce, safety, and ethical responsibility. At this stage of our journey, it is natural, and entirely reasonable, to pause and ask a deeper human question: what does this mean for the people who build aircraft today? Any discussion of humanoid robots in factories must be approached with care, empathy, and honesty. In industries such as aerospace, workers carry immense responsibility. They bring experience, judgment, and accountability that no machine can replicate. The introduction of humanoid robots does not remove this reality. Rather, it reshapes how responsibility is shared. If Airbus moves forward with this technology, safety will remain non-negotiable. Human-robot collaboration requires clearly defined operating zones, predictable robot behavior, redundant safety systems, and extensive testing before any meaningful integration occurs. Aerospace standards leave little room for improvisation, and robots must conform, not the other way around. There is also the question of employment. History shows that automation rarely eliminates work entirely. Instead, it changes the nature of work. Repetitive, physically taxing, or ergonomically harmful tasks are often the first to be automated. This can reduce injury and fatigue, but only if accompanied by thoughtful workforce planning. Ethical responsibility therefore extends beyond the factory floor. Companies must invest in retraining, upskilling, and transparent communication. Workers deserve to understand how new tools will affect their roles, and they should be involved early in testing and feedback. Trust cannot be commanded, it must be built. Finally, there is a broader ethical dimension. Humanoid robots blur psychological boundaries because they resemble us. This makes clarity especially important. Robots are tools, not coworkers with agency or accountability. Decisions, liability, and moral responsibility remain firmly human. This section of the story reminds us that technology alone does not determine the future of work. Human choices do. In the final section, we will look ahead, toward possible futures, risks, and opportunities shaped by the decisions made today. Looking ahead, what this may lead to. As we reach the final section, it is helpful to step back and look beyond this single trial. What Airbus is exploring today may help shape how advanced manufacturing evolves over the next decade, not only in aerospace, but across many industries. There are several realistic paths forward. The most likely is gradual adoption. In this scenario, humanoid robots become specialized assistants, handling narrowly defined tasks that benefit from mobility and endurance, while human workers continue to lead planning, judgment, and certification. Progress would be steady, cautious, and guided by evidence rather than ambition. Another possibility is deeper integration. If testing proves successful and standards mature, humanoid robots could become a familiar presence in factories, not replacing human teams, but augmenting them. Battery swapping capability would allow robots to operate reliably across shifts, making them practical long-term assets rather than experimental tools. Over time, suppliers and training programs would adapt, creating an ecosystem around human-robot collaboration. A third, more uncertain path involves acceleration. Rapid advances in artificial intelligence, sensing, and materials could push humanoid robots into broader roles more quickly than expected. While this could unlock efficiency, it also carries risks, from workforce disruption to over-reliance on immature systems. This path would demand strong governance, international standards, and ethical restraint. What unites all these futures is choice. Technology does not arrive fully formed with a predetermined outcome. How humanoid robots are deployed, who benefits, who decides, and who is protected, depends on policy, leadership, and values. This story, then, is not simply about robots or aircraft. It is about stewardship. Airbus's trial is an early chapter in a much larger conversation about how humanity integrates intelligent machines into work that carries real responsibility. As seekers, our role is not to fear this future, nor to rush toward it blindly, but to understand it, patiently, thoughtfully, and with care. As we come to the end of this exploration, it is worth taking a quiet moment to reflect on what we have truly discussed. This story is not only about humanoid robots, battery swapping technology, or aircraft assembly lines. At its heart, it is about how humanity chooses to introduce intelligence and automation into places where precision, safety, and responsibility matter deeply. When a company like Airbus pauses to test, not rush, not promise, it reminds us that progress does not have to be reckless to be meaningful. The arrival of humanoid robots in factories does not mark the end of human skill. Instead, it challenges us to redefine how skill is expressed, protected, and passed forward. Machines may assist, carry, and repeat tirelessly, but judgment, accountability, and ethical choice remain human responsibilities. Battery swapping robots symbolize something subtle but important: continuity. They represent systems designed not for spectacle, but for reliability, for quietly supporting long, complex processes without demanding constant attention. And in industries like aerospace, quiet reliability is often the highest achievement. As seekers, we are not asked to celebrate or fear this future blindly. We are asked to understand it, to ask careful questions, to examine who benefits, who is protected, and what values are embedded in the systems we build. If this video has helped you see this topic with greater clarity, I invite you to continue the conversation. Share your thoughts, your concerns, or your questions in the comments. Your perspective matters, especially in discussions that shape the future of work and technology. Thank you for giving your time and attention. If you wish to explore more thoughtful discussions like this, consider subscribing and joining this growing community of curious minds. Until we meet again, remain thoughtful, remain curious, and above all, remain human.